The data set that I've chosen for this semester project contains thousands of college students' academic performance variables ranging from test scores to assignment scores to average number of hours studying a week, that type of stuff. My name is Jackson Cushing. So just to give you a quick introduction to it, I've always considered myself a relatively conscientious student ever since I was young, and while I was looking for a data set to analyze for this project, when I stumbled upon this one, I thought it was pretty interesting. I've always thought I've had a pretty good handle on what works for myself academically, how to maximize my output. But I thought it'd be interesting to try to see if there are any underlying tendencies among the masses, to see if there'd be a new way to help my own academic performance. And then I just had first couple rows of the table there. To give you more of a brief snapshot of it, there's going to be 5,000 total individual students that are in this data set, along with 23 distinct predictors. So quite a large data set. And then right off the bat, there were some issues with the data set that Kaggle showed me. First of which, there are missing values in every row, and they aren't equal. It's not like one column is missing for all of them. They're scattered all over the place, so that makes things difficult off the bat. The owner of the data set says that there's some bias towards students with higher attendance, where the professors will give them higher grades than those with lower attendance. And then as well, there are going to be some imbalanced distributions, because some departments have more students than others. So right off the bat, there will be some challenges to overcome. So to take a more deeper look at the variables themselves, the first 5 above this are just identifiers: first, last name, email, student ID, that type of stuff. Then the rest, they range anywhere from different scores on assignments and quizzes and attendance, and then more categorical stuff such as stress level, family income level, parent education level, internet access at home. So it's a very mixed data set with numeric as well as categorical variables. So to start, even though I knew this wouldn't be very helpful, I just wanted to have somewhere to start. So I chose to train a full model using all 23 of the variables, and naturally none of the predictors are statistically significant, and the residual plot, this model is not useful at all. It was just a place to start. Moving on from that, I asked R to run forward, backward, and stepwise selection to see how many variables that it would end up keeping out of the 23. And well, you can't see very well on the top with backwards, forwards, and stepwise. They all omitted all but one variable, and that's participation score. And that variable itself was not even statistically significant. So it's nice that all three of the selection methods only use participation score, but again, not very helpful for us. Additionally, because of the bias initially, which we stated right here, the higher attendance gets higher grades. It becomes even more unhelpful because this becomes even more unhelpful because we already know that participation score has a positive relation with total score. So moving on from that, wasn't very helpful. I now wanted to try dimension reduction because we have all these predictors. I felt that it would be a better idea to try to reduce the dimensions and see if we could get a better beat on what the two dimensions may be. So to start, used principal component analysis to find the two biggest principal components and plot there. As you can see, if you couldn't see from there, there is literally no patterns anywhere there. So very unhelpful. That's just all four colors all over. We then tried the T-distributed stochastic neighbor embedding dimension reduction technique to see if that would give us any better of a model. There are a bit of separations here, and here, but again, that doesn't really tell us much. All four of the levels of the total score, which was my target variable, they're all over the place. There are no real conclusions to draw from this, so we move on to dimension reduction with non-negative matrix factorization. Now, while these points give us or show us that there is a negative relationship between topic 1 and topic 2, we know that negative relationship has nothing to do with score levels, as there are green, red, blue, and purple all throughout here. There's no cutoff at a certain point for any color. They're all along the ways. So we can determine that a negative relationship exists between topic 1 and topic 2. But what that is, we can only guess. So I wanted to see if I could somehow use BNLearn for this scenario, because I knew that a mixed data type data set such as this one would be very difficult to use BNLearn with, because BNLearn struggles quite a bit with mixed data types, and I confirmed that while trying a couple times to get it to work. So I thought, what if I omitted all the numeric variables, such as like all the different scores, because they're all scores. They all average up in one way or another to get the total score. So I thought maybe with just the categorical variables that are still important, all of them play some factor into how students do academically, but it's not as easy to tell numerically or graphically due to them being categorical variables. So I attempted to make a Bayesian network with the factors only. Here they are all labeled. However, it's just as useless as the full model from the very beginning. There's nothing we can discern from this, no conclusions to be drawn. So, where can we go from here? It seems as though whatever model I tried to do, just the only conclusion that can be made from those models is that this is unhelpful and we can't reach any meaningful conclusion from them. So how can we fix that? To start, having the missing values in each row massively complicates this whole ordeal. So if we were able to clean the data set and maybe have a better method of writing down or tracking the data in the first place, that would be great. If that were the case, we could then use the methods described earlier in this presentation much more effectively, and we may be able to draw much better conclusions than what we were able to do in this presentation with what I was given. Thank you.